Hello everyone, my name is Franco Pucci and I'm the technical consultant for the STS Association. I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this video, we will deal with section 6.5 of IEC 62055-41 edition 3, and that is security functions. Let's look at vending key classifications 6522. There are 4 different key types associated with STS, each associated with an HGC type, a vending key type, and key type 0 is an initialization SGC, and the vending key is not specified for this simply because that is the only key that is available on in a readable form and is not generated using a vending key. Key type 1 is a default key or default SGC. That's a vending key type DTEK, and that can only be used to generate default decoder transfer keys or DTEK decoder keys. Key type 2 is unique key, vending key type VUDK, and it used to generate DTEK decoder keys. And then last but not least is key type 3, which is a common key, although it's not that commonly used anymore, vending key type VCDK, and used to create a DCDK decoder key. A vending key is secretly generated and is used and stored within the key management system. It is never visible in plain text. It is also the property of the STS Association and allocated for exclusive use to a supply group user. Decoder key classifications 6532. DTEK for a decoder key is the initialization key. A DTEK is a default key. On a default key, you cannot vend any credit. On a DTEK, you can. On a DTEK, it's a uniquely coded key, which means each meter has a different key. The common key, which is key type 3, means each meter within a supply group code has exactly the same key. The decoder key is derived from the vending key, with the exception of the DTEK. It must not be possible to extract the decoder key from the meter in any form whatsoever. A meter must be able to store at least one decoder key. Now let's look at the DTEK in particular. That's section 65232. DTEK values are used to initiate or initialize the decoder key register during production or repair, and those are put in manually on the production line. It is a property of the meter manufacturer. The meter manufacturer selects his own DTEK at some point and then uses that going forward. It's generated and managed by the manufacturer. So the STS Association has nothing to do with DTEKs, nor does the KMC. Meters may never leave the manufacturer coded with the DTEK. For obvious reasons, the key is known by somebody. It can be introduced into the payment meter as a plain text value. This is the only key that can be introduced as a plain text value. And it can be used as a parent key for DTEK, 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 or DCTK, all using key change tokens, except DTEK. It can encrypt or decrypt management and credit tokens. The decoder default transfer key or DTEK, those are used to initialize the decoder key register during production or repair to a default key, which may later be changed to either a DU, DC, or DD. These are used for when you're shipping a large volume of meters into a warehouse at a utility. The utility doesn't know exactly which supply group code they'll be going to, so they get them all in a default key. And when they know where the meters are being shipped to, they key change them to the correct supply group code. These are allocated and managed by the meter manufacturer or the utility. Meters may leave the factory coded with the DTEK. Can only be introduced into the payment meter via key change tokens. And they can be used as parent keys for DD, DU, or DCTK. They can encrypt or decrypt management tokens. Meters cannot accept any credit if the meter is coded with a DTEK. A POS may not generate credit tokens using a DTEK either. Then you have the unique key, the DTEK 65234 is the clause. DTEK values are used to initialize the decoder key register to a unique decoder key valid for a specific meter decoder reference number. Meters may leave the manufacturer coded with a DTEK. They can only be introduced into the payment meter via key change token set, and they're used as a parent key for DTEK or DTEK, not DCTK. So you cannot go from a DTEK to a DCTK. Can encrypt or decrypt management and credit tokens. Then you have the decoder common transfer key or DCTK. DCTK values are used to initialize the decoder key register to a common decoder key valid for a specific group of decoder reference numbers. Meters may leave the manufacturer coded with a DCTK, and they can only be introduced into the payment meter via the use of key change tokens. Can be used as a parent key for DD or DCTK meters. They can encrypt or decrypt management and credit tokens, and they can only be used in meters with an erasable token carrier type like a paper token. Meters with the token carrier types other than TCT01 must reject tokens coded with a DCTK. Now we'll have a look at the key change state diagram shown in 6524 of the IEC document. If you have a look at the key types that we have mentioned, we have a DITK right at the top, then you have a DDTK, a DUTK, and a DCTK. What functions do we have? We have credit transfer functions and management functions that tokens can do with a meter essentially. Now let's look at the key changes that are allowed. So first of all, key changes to a key itself, all of them. So you can go from DD to DD, DU to DU, DC to DC, or DI to DI. So any one of these keys can do a key change back to themselves. If you have a look, DI to DC is allowed. So you can go from a DITK to a DCTK. You can also go from a DITK to a DUTK or a DITK to a DTK. Those are all allowed. Then you can go from a default key to a common transfer key and back the other way, common transfer key to a default key. You can go from a DD to a DU, and you can also go from a DU to DD. Then if you have a look at this one, you can go from a DCTK to a DUTK, but you cannot go from a DUTK to a DCTK. Okay. Supported under the DITK, the functions supported are management functions, that's the dotted line, and credit transfer functions. Supported under DDTK, on DDTK, you can go from, you can do management functions only and not credit transfer functions. Under DUTK, that's the purple ones, you can do management functions or credit transfer functions. And under DCTK, you can do credit transfer functions or management functions. Or in tabular form, and that you can find in table 33 of the IEC spec. If you look at the parent key and the child key, you can go from DITK to DITK, you can go from DDTK to DITK, etc., etc. You can't go from DD to DI. So in fact, from any of the DD, DU, or DC, you cannot go back to a DITK. All the ones that are in orange are for meters with token carrier type 01 or the MAG card only. Next we'll talk about key revision number, which is in 6525. The key revision number uniquely identifies a vending key within a supply group. Together, the supply group code and the key revision number uniquely identify a vending key. The key revision number is a single-digit number in the range from 1 to 9. Successive vending keys are assigned successive K or N values. A payment meter's decoder key is associated with the supply group code and the key revision number. And the concept of a KRN only applies to VDDK, VUDK or VCDK, not the initialization key. The meter must store the KRN value of its decoder key somewhere in non-volatile memory. The key expiry number sets the key expiry date for vending and meter keys. The POS may not generate tokens with a TID after the key has expired. So obviously if the token has a TID, then it can't generate it. If it doesn't have a TID, like a key change token, it can. The meter may not accept tokens after the key has expired. The POS may not generate key change tokens to change a meter key. The KEN is transferred to a meter in the key expiry number high order and the key expiry number low order fields in a key change token set. The meter may optionally implement key expiry using the KEN if it wants to, or you can set the KEN to all Fs, in which case it doesn't ever expire. Each bit in the 8-bit KEN corresponds to 45 days from the base state start. This brings us to the end of this part of the video series. I hope you found this video useful and hope you will join us for the rest of the series. Goodbye and see you again soon.